Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Phobos, Doomed Moon of Mars. So what do we see here? Well, here we see one of the two moons of Mars, and there are only 3 moons in the inner solar system. So among 4 planets, there are only 3 moons, 2 of them around Mars, and of course our own large moon around Earth. Now, Mars's moons are much smaller and are believed to be captured asteroids, meaning that they came too close to Mars and happened to be captured in its gravitational field. Now, to just capture an object randomly is relatively difficult. It's very easy to put something in orbit when you can adjust the positioning and the speed as you approach, but an asteroid doesn't get that. It comes at whatever way it happens to be coming. So the reason Mars might have captured several asteroids, whereas the other inner planets did not, is perhaps because Mars is so much closer to the asteroid belt and had many more chances to catch those asteroids. Now, Phobos here is being imaged by the Mars Reconnaissance Orbiter imaging Mars, and we can see a lot of detail, including the large crater off to the right-hand side, which is known as Stickney crater. Now, this moon is called the Doomed Moon because it only has a short amount of time to live. Not by our standards, but by astronomical standards, it will not last for a very long time. So, in roughly 40 million years or so, this moon will be gone. And that's because it is in a very low orbit around Mars, much closer than what we're used to with our own Earth. This orbits Mars at a distance of less than 6,000 kilometers. Now, for comparison, our moon orbits Earth at 400,000 kilometers. So it's in a very low orbit and it's slowly decaying. As it does that, it will get closer and closer to Mars, and the tidal forces will start to tear it apart. So eventually, Mars will have a ring, and maybe for 1 million years or so, Mars will actually have a ring when this breaks up. The tidal forces means that there's a differential force, that Mars is pulling on one side far harder than it is pulling on the other side. Now, far enough away, that doesn't make much of a difference. But when you get closer and closer, eventually you can get to the point where the moon can no longer hold up against that force. That the force on one side will be too much stronger than the force on the other, and the moon will tear itself apart. And that's actually what those lines going across it were once thought to be signs of the moon starting to fracture under the stress of Mars's gravity. However, more recent studies have shown that that's probably not the case, and that it's more likely that they are from material that was ejected in the crater that formed, the Stickney crater off to the right-hand side, and more that material that just kind of rolled across the surface of the moon, leaving those trails behind it. And at least that's been the more modern explanation for the last 5 to 10 years that astronomers have come up with. So here we get to see Phobos, the doomed moon of Mars, as it still exists today, but many millions of years from now will be gone. So that was our picture of the day, titled Phobos, Doomed Moon of Mars. We'll be back again tomorrow for the next picture, previewed to be Bubbling Galaxy. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.